Okay, hello everybody. Today we will continue talking about separate compilation and namespaces, and I will start our new chapter, recursion. I will not give any breaks today, but I will stop 15 minutes early at the beginning of the hour at 11 o'clock. Let's continue our discussion with the namespaces. We said that last time. Namespaces are actually generalization of the encapsulation idea. We try to keep things local. We try to encapsulate things that are related to each other, and we try to hide the details that are not necessary to the outside world for ourselves. We don't expose those details, and namespaces are kind of a tool for achieving this purpose. Let me show you how the class defines this idea of namespaces. Yeah, the definition of namespace is just collection of name definitions, and that's no problem. We talked about this, and there was a slide. Okay, no, I couldn't find it, but okay, we will come to that later then. We said that namespaces are actually generalization of the encapsulation idea, and we say that these things are related, these classes are related, these functions are related, these variables are related, whatever they are, and we put them in the same capsule and we give it a namespace. Okay, whenever we need to use this namespace, we just say that I am using this namespace, and the compiler makes it available. They did the same thing for the standard namespace. They say that all kinds of C++ libraries, they are all defined in the namespace std. If you like to use them, you have to tell the compiler that you will use them, all of them, or you may tell the compiler one by one which ones you are going to use, and the compiler will make it available to you. This standard namespace is not supposed to be modified. It is standard, right? It has its own behavior, so don't change that behavior. I don't like this. Okay, so we are supposed to just use the standard namespace, and this is how we do that. Okay, so this is how we say I am going to use the standard namespace in my program at the beginning of the usually the program file. Okay, if you don't want to use the standard namespace, then don't mention this one, and making these kind of class definitions or the global variable definition is okay. You can say that cout is going to be an integer. Okay, don't do this, of course. This is very confusing. don't do this, but it is possible if you like to do it that. Okay. So we talked about that, and we talked about the standard namespace, and we talked about the global namespace. We said that in C++, whatever you define, either a function or a global variable or a class, it has to go to some space, some namespace. Okay. If you specify your namespace, you are fine. Your new definition, class definition, will go to that specific namespace. If you don't define anything, if you don't say anything about the namespaces, whatever you define will go to the global namespace. Okay. So global namespace doesn't have a name actually. Well, its name is global, but we don't mention that. Let's start from the top part. Sorry. But somebody's smoking, I feel. Are they smoking there?
Here.
Are they smoking? Sigara içiyorlar mı orada?
Hocam az önce içiyorlardı da gitti.
Ha, gittiler mi? Ya da sigaraları bitti. Sigara içenlerden hoşlanmıyorum ben, neyse ya. Kimseye söylemeyin. So global namespace is something that you have been using all along. Okay. Nobody told you that until last lecture, but everything goes to this global namespace. To use the global namespace, you don't say using namespace global, etc. You just use it. Okay, so that's one thing to remember, and we are going to talk about this in a few minutes. Multiple namespaces are always available. Well, we didn't know anything other than the standard namespace, but you can have more than one namespace. And since you have more than one namespace, you can have more than one space. It is possible to have two declarations, two class declarations with the same name, as long as they are in two different namespaces. Okay, so we will give some examples of that. For example, here, suppose you have two namespaces, ns1 and ns2. Okay, and within the scope you are saying that, in this scope you are saying that, okay, I will be using the namespace ns1 in the scope. When you call this my function will come either from ns1 or the global namespace, okay, because global namespace is always available. And here ns2, okay, ns2 is available here. Here my function will come either from ns2 or the global namespace. Okay, but I know that my function can be defined. See that my function has exactly the same signature. Its signature is my function and no parameters and etc. It has exactly the same signature, so you may have the same signature, exactly the same signature in two different namespaces. Okay, good. So we talked about this specifying namespace, and you have more than one namespace. If you have more than one namespace, you may have the same function declaration or same class declaration in two different namespaces. So I think last time we stopped here, we said that if you like to use your own namespace, just make a new namespace. It's just like a class definition, right? You say namespace name, okay, and some code, and that's it. It's like really a class definition. How do you define the class? Class my class, etc. And this is the class definition, and this is the namespace definition. Okay, namespace and C, my code, and curly bracket, and there is no semicolons there, right? So whatever you do, you define inside this namespace, it will go to this namespace and see. Okay, so here is another example of using namespaces. Usually we separate our interface from the implementation, right? We separate our interface from the implementation. What does that mean? That means that I have my header file and I have my implementation file, both of them. Okay, so in my header file, I define the function's prototype or the function declaration, the parameters and signatures, etc. In my implementation file, I have the function implementation. And if I am putting all these, the function declarations and the implementation in a namespace, then I have to do this. I say that inside my header file, my header. Okay, inside my header file, you would say this is my function prototype, but I am placing this function prototype inside this namespace space 1, and in my implementation file, I would say, okay, I am going to put more definitions in my namespace, and here is my function implementation. This is possible. So remember, when you do when I say it is very like class definition, when you start a class definition, you have to put everything in there, right? Of course, other than the implementation. Okay, you put all your functions, your data, and etc. Later you may implement them, but when you start defining a namespace, okay, you define part of it here, you define part of it somewhere else, like this. I define part of my namespace here in my header, and I define part of it in some other space. So this is called, okay, this is called making a new namespace, and from now on in your homeworks, you are going to use this mechanism of encapsulation. You will always have your own namespaces. Okay, so what do we choose as our namespaces? Of course, it has to be something meaningful. For your namespace, it has to be something meaningful. Don't choose a namespace like alpha 1, alpha 2, namespace 1, namespace 2. Okay, use a namespace that makes some sense. And usually we choose unique namespaces, like for example, your last name, your institution name, Gebze Technical University, or your company name, etc. in your namespaces, because namespaces are supposed to be unique. They shouldn't be confused with somebody else's namespace. Okay, so up to now, we said that, okay, I am going to use this namespace, okay, or I am going to, I said something like this all the time, okay, using namespace ns1. So this statement made the whole namespace available inside the scope, and this namespace statement made all the namespace to available inside this scope. But sometimes, okay, sometimes I like to say things like this. Okay, there is a namespace named ns1, but I don't want to use all the definitions inside ns1. I just need to use fun1, okay, function 1. So this is what I do. This is using declaration, okay. This is using declaration. The other one is the other one of using is using this one is, okay, let me, one is a definition, one is a declaration, okay, one is a directive, one is a declaration. Using directive, this is the one that we use all the time. Using namespace std, okay, is a using directive. But if you say using std cout, is a using declaration. Okay, declaration and directive. It's like you are declaring a variable, right? Of course, you are not declaring anything, but you are declaring a variable. So it's a declaration, but this is directive. Okay, so both of them are available, and depending on your needs, you choose one of them. Okay, so this is the declaration syntax. Inside this namespace, I am going to use this one. It's like declaring a new one, but of course, but you are not declaring. So just a naming issue here. So we talked about how to call these kind of stuff. Sometimes the third way of using namespaces is directly calling the namespace, directly calling the function inside this namespace. Okay, there is a namespace named ns1, and inside that there is a function. Okay, its name is function1. I am going to call that function. For this one is not a declaration nor directive. Okay, this is just using the qualifying name syntax to call the whatever we need to call from that namespace. Okay, so this is sometimes very useful, especially for the parameters and etc. And we'll talk about it later. Okay, so I talked about this, I guess, right? So I talked about this. I said that you use a unique namespace that will not be confused by somebody else. It's a very bad idea to choose your namespace as std. It is used, right? Okay, so don't make these kind of very general namespaces, like your last name, your company name, your university name, etc. So we talked about that too, and let's look at the examples from the book. Inside those examples, we have namespace. Where is it? Did I get it? Okay, yeah. So let's open some. Okay, so this one, okay, so they made this time. Remember our time class time. Okay, let's just remember it. This is our header. Okay, inside my header I said that this is my class digital time, and inside this class I have the constructor getters and some advanced function overloaded. You remember this, and the comparison and the insertion extraction operators. Okay, so maybe this is not the one that I wanted to show you. Let me see the other example if it is. Yeah, this one is a better one. Okay. Let me close this one because this one will come. Okay, let's make sure nothing is confused. Okay, so my header, I say that this is my class definition, but I am defining this class inside this namespace d times savage. Savage is the last name of the class, the book author, and d times savage is my library for this time-related functions and classes. I have my class time, digital time definition inside this namespace. Yeah, that's one thing. And when we go to the d times cpp, okay, inside d times cpp, of course I include my d time age, and remember in my d time age I have my guards against the multiple inclusions. Okay, I say that I am going to continue putting more stuff inside my namespace d times savage, and I put all of my implementations, and that will be it. Okay, and okay, thank you. Did everybody sign this? No. Anybody? Okay, after the class you come here and sign. Okay. And when we come to the main function, our main driver program, okay, when we come there, I include d time h, and I say that I am using, okay, namespace d time savage. And remember, main doesn't go to any namespace other than the global namespace, okay? Main has to go to the global namespace, okay? Main has to go to the global namespace. If I say namespace, okay, d time savage, and do this if I declare everything inside this what? Oh, I didn't. Okay, if I put everything inside this definition, my main goes to d times savage namespace. It will compile, but it will not link. Why? Because the linker needs a main function that lives in the global namespace. Otherwise, how do you qualify the name main? Main has to be called d times savage scope resolution operator main, right? So this is not the main that you know for the last year, okay? This is a new main that lives inside this namespace d times savage, okay? It is different from the main that has to go to the global namespace. So don't put your main inside any namespaces other than the global namespace. So I did that, and I compiled it, and it works fine. So if you like to use this digital time, you have to use this line number 6 using directive, okay? Using directive. Or you could do just this, okay? You could do just this. I need digital time objects clock and old clock, but both of, okay, this digital time belongs to this namespace d times savage, okay? So by including this d time.h doesn't make the namespace d times savage available for me. I just included it. I had a namespace inside this d time h. I have this namespace definition, and inside the namespace definition I have the digital time. But if you like to use anything inside that d times savage, then you have to say so. I'm going to use it from there. Okay, I think this should compile and run, because other than that, I didn't use any namespace definition, etc. Okay, any questions about namespaces so far? Yes?
When you don't include the namespaces, shouldn't you also use...
well, there is no such thing as including the namespace. There is namespace declaration, and there is namespace declarations, and there is namespace directives, okay? You don't include a namespace. Including a namespace, if you like to call it that way, including a namespace is like including a class definition, okay? So when you include this header file, you say that whatever written in this header file, just compile it too, okay? So this part, this header file, how many lines? It is like 57 lines of code, becomes part of your code. So this line 5 will be expanded to 57 lines of code, okay? That's called inclusion. You don't include the namespaces, you just use them. You just like the class definition, okay? You just define them. So what is your question again?
Pardon me, then why don't you use the namespace for the member functions also?
Oh, you mean the advanced, etc.?
Yes. Functionality.
Well, I mean the compile. What is the type of clock?
Digital time under daytime savage namespace.
Well, yeah. The type of clock is not digital time. The type of clock is daytime savage, scope resolution, digital time. Okay. So when the compiler checks line 20, clock.advance, it knows that clock belongs to a digital time class, which belongs to daytime savage namespace, right? So it already knows it. I mean, so something you are saying that I am going to call clock.daytime savage advance. That wouldn't be wrong because there is no function named advance inside daytime savage. Advance is part of the class digital time. Okay. The first thing is this is wrong. The second thing is that I don't have to say such a thing because the compiler knows the type of clock, which is the digital time savage digital time. That's why you don't mention after that. Okay, so that was a good question. Any other questions? If I do this, would it compile line 6 and line 12? Would this compile? Remember line 12? I inserted this.
I think it would.
No. I think no.
Yes, it will. It will compile. What is wrong with qualifying the name even more? Okay, you are saying that I am going to whatever I say will come either from the global namespace or the daytime savage, okay, and or STD. There are three namespaces happening: STD, daytime savage, and the global namespace. Okay, so when I say C in, this will be looked up inside STD or daytime savage or the global namespace. It has to be in one of them. Or I can say for this one you don't have to look anywhere. Okay, this one is available inside daytime savage. I'm giving you the exact address, so no problem doing this. But of course we shouldn't do that. Why should we do that? Okay, because it is already available. Good. Okay. Any other questions? So let me move on then. Let me move on with the slides. We talked about this. Okay. Did I have this 11.7? Is this 11? Yeah. Well, let me open this other one, which is yeah, we already know that. Okay, let's look at this one. I have two namespaces, space 1 and space 2. Very simple program. Okay, I have two functions, greeting and greeting. Their signatures are exactly the same. Okay, it looks like you are going to get a compiler error. Line 7 and line 12 are exactly the same, but no. Why? Because I am placing them in two of them. Okay, I am placing them in two different namespaces, and in my main function I say that I am going to use now the space 2 greeting. Here I am going to use it with the space 1 greeting again, and then this big greeting will come from the global namespace. Okay, it will come from the global namespace. How about this? If I do, is this a compiler error?
No.
Is it STD?
Just look at this. Okay,
Oh,
I define three greeting prototypes: space 1, space 2, and the global namespace. So this is not a compiler error. How about this then? How about this? Is this a compiler error?
What's this function called?
This is a compiler error, right? Why? Because line 31, compiler doesn't know which greeting to call. Oh, no, this is not a compiler. I'm sorry. Yeah. Because I didn't say I'm going to use the namespace 1 or namespace 2, right? This is not a compiler error, right? But this one is a compiler error, and this one is a compiler error. I don't have to write it. Okay, so I get rid of this one. So when I say that, okay, line 16 is not a compiler error, but this is a compiler error. Why? Because when this one calls greeting, the compiler doesn't know which greeting to call. The greeting from the space 2 or greeting from the global namespace, right? So how would you solve this problem? Maybe I can solve this problem by directly specifying, okay, when I say greeting, it is a greeting from the space 2. Well, in that case, I will not need this line 21. Okay, so it is always important to remember that here, whatever you put, it goes to a namespace. In this case, it's going to be a global namespace, and global namespace is always available. You don't say I am using global namespace and etc. So let me get rid of them and do this. This one will come from space 2, space 1, and big greeting. So somebody has to implement this. How do you implement it? Inside space 1, the greeting function hello from namespace space 1, and hello from namespace 2, and this is a big global hello. Okay, big greeting. Okay, so that was it. So I showed you all the book examples, and this one we looked at it, and let's look at the final important concept inside this namespaces. Unnamed namespace. Okay, so unnamed namespace, like the global namespace, is a special one. It is defined, it is already there. Okay, but to understand what unnamed namespace is, we need to look at this concept of compilation unit. Okay, important concept in C and C++, compilation unit. Okay, a compilation unit is a file along with all files included in the file. Okay, so when I say a C++ program file, for example, let's look at this application CPP. Okay, you will say that, okay, this is just 36 lines of code, this application CPP, but the compilation unit for this file is this 36 lines plus the lines that you have included from d time h. Let's go to d time h. D time h is 57 lines, so 36 plus 57, it is 90 something lines, but this one includes this IO stream too, so I have to include inside my compilation unit IO stream, and IO stream I bet is going to be a few thousand lines long, because IO stream includes other headers too. So the compilation unit for this application CPP will be more than 3,000 lines maybe. Okay, and in fact maybe I did that somewhere. Let me see if I can find it. I think I compiled it for somebody. I hope I did not erase it. Maybe I did. Yeah, this one, rest.cpp. Let me see. So it is 546 kilobytes C++ code, and this one is produced by our preprocessor. Yeah, time demo CPP. I compiled time demo CPP with a flag minus what? Minus S. Which one did this? Remember the compiler flag that says that don't compile this program, just run the preprocessor and stop. What was the option? Minus Nobody remembers it?
Minus E.
Minus E,
Yes.
capital E, right? Yeah, minus E. So it was minus E. So I compiled it with minus E, okay, time demo, and it included IO stream, and as you see, IO stream has lots of stuff, template definition, etc. The interesting part is at the at the bottom of it. Okay, see, my main function is here at the line 23,000 something something something, and before that, this is my header file that I have included. Okay, this is my header file that I have included. Okay, and before that, everything comes from the IO stream, etc. So what I am saying is that this simple definition of compilation unit, a file along with all files included in the file. Okay, although the definition is very simple, the compiler has to do lots of stuff for the compilation unit, because compiler has to compile this 27,000 lines of code to compile your time demo CPP. Okay, and whatever the compiler compiles for that single line of G++ time demo.cpp is called a compilation unit. Okay, so why are we talking about such a thing now? Okay, it sounds nice, but what does this has anything to do? What does this have anything to do with the namespaces? This is what we are going to say. Every compilation unit has an unnamed namespace. Okay, exactly one unnamed namespace. Okay, as the name implies, there is no name for the unnamed namespaces. They don't have any names. Okay, and since it doesn't have a name, there is no way then you can use them outside of that name, outside of that compilation unit. Okay, you can't say that I am going to use unnamed namespace now because it doesn't have a name. So what is this good for? It is good for keeping things local for that compilation unit only. Okay, whatever you defined inside an unnamed namespace stays inside that compilation unit, and nobody other than the compilation unit elements can use those definitions. Okay, let me show you one example. Let me show you one example from the book. Remember the example that I tried to hide you, not to scare you off? I am going to show you now. Don't get scared. So this one, yeah. This one says, I have a header file, okay, dTime_h, nice cards, and I am not going to say using namespace. There is no directive, etc. I am just using the full qualifying names here using stdio stream, and everything is defined. Okay, did you see this missing private functions? Remember, I didn't like those functions. What was the functions? Into, character, and etc. I put them inside this unnamed namespace. Okay, unnamed namespace. Inside the unnamed namespace, I think that there is something funny going on in this here, right? Just a minute. No. I modified this one from last year. They shouldn't be here. Let me get rid of these. Okay, good. Okay, now say this. Okay, so my dTime_h is no problem. It is exactly the same as before. The only thing is that I don't have the private functions that converted a character to an integer and the read out, etc. They are not there. But when I look at this dTime_cpp, inside dTime_cpp, I have an unnamed namespace. Okay. As you see, it doesn't have a name. It doesn't have a name. This is unnamed. That's why we say that it is not possible to use this namespace outside of this compilation unit. Digital digit to end, and read minute is available, and read out is available too. And then I have some addition to my namespace d times average. And we already looked at this definition right before. Okay, so what I did was I placed those three functions. So line 14, digit to int, it doesn't belong to my digital time class anymore. It's not a private. It looks like it's a global function, right? And at the beginning of the semester we said that we don't like global functions, and this is a global function. So what was the solution for this one? We made them private functions to our classes, but as a private functions, I didn't like them either because they are not part of our class. They don't work on our data. It is not. It is against the principle of the encapsulation. Okay. I can't. Okay, in a few minutes. It is just a. It is not just part of the class definition. It is just looks like a global. I don't want to make them global. Well, let's keep them private for now. And later we said that just to tell the compiler that these functions will not have an access to the private data or any data, I made them static. Still, I don't like them because these are not part of the class. I made them global now, but they are global in the unnamed namespace. So what does that make them? It makes them local to this compilation unit only, because outside of this d times CPP compilation unit, nobody can have access to digit to end or read minute functions. Okay, so I kind of kept my promise of encapsulation. I put related things together, but I didn't put them in my class because they are not working on my data. By putting them in this unnamed namespace, nobody other than the people in my d times CPP can have access to digit to int function. So I satisfied both encapsulation principle and not using any global functions. Okay, these are not global functions anymore because they're part of the unnamed namespace. Okay, but this is different. Okay, this operator stream extraction is part of the d times average. This is not unnamed namespace. This is available to all of my customers as long as they use this name d times average. Okay, so let's see how. Let me see. Okay, where do I use this d time end digit to end? Can I find it? Find here and find. No. Okay, forward. It is inside this line 14, and it is line 31. Well, digit I can call it because I am inside the same unnamed namespace. And what else can I do it? Where is this 53? Again, inside this namespace it is all okay. So I guess that's it. So it is okay for me to use this digit to int inside this unnamed namespace or the whole compilation unit, and read out and read minute. Okay, they are defined inside the unnamed namespace of this file. Okay, that's why it is available, and I can call them. See, this one is in namespace d times average, and read minute will be correctly called from this unnamed namespace. Let's go to this d time demo CPP. Okay, surprise, line 7, read out. It has exactly the same. Signature as this line 41. Remember this one as in the unnamed namespace. See, it has exactly the same signature. So what's going on? What is read hour here? And can I put these windows side by side? No?
I think Control M.
Control what?
M.
Control M. Okay, good. Thank you. So this theta, okay, Control M just separates into another one. So this is my time demo CPP. Let's go to this one. So read hour, okay, is here, and read hour is here. Okay, this one, okay, how about this one? Line 7, read hour. What is the namespace of read hour? Global namespace. What is the namespace of this 41 read hour? Unnamed namespace of, there is no one unnamed namespace. There are as many unnamed namespaces as the number of files that you are compiling, or as the number of compilation units, right? Well, how many unnamed namespaces? It depends on how many compilation units you have, okay? For this program, how many compilation units do I have? Time demo CPP along with all of its includes, and dtime CPP along with all of its includes, right? So there are two unnamed namespaces for this example. So this read hour belongs to the unnamed namespace of dtime CPP, and I didn't define any unnamed namespaces for the time demo CPP. So this read hour and this read hour are very, very different. Compiler will not get confused about this, and so I need to implement this one somewhere in this compilation unit time demo CPP. Okay, so our main is here. I am saying that I am going to use the CLC and etc. I am going to be using this digital time. Okay, and I am going to call this read hour here. This read hour is not this one. So how do you call this line 41 from, okay, this read hour is this one, right? Line 7. How do you call 41 read hour from line 18? How do you call it?
I think you can.
You can't. That's the idea. It is not available. It's like the private function of some class, right? It is not available. Because if you like to call them, what is the name of this namespace? Unnamed. There is no way then you can specify it, right? You cannot say that unnamed namespace of that one. But if you like to call the dtime savage unnamed something from dtime savage namespace, then like I did here, I would refer it that way. So this read hour definitely calls this one, and this read hour inside this class, inside this dtime CPP, is not available to me. It is hidden from me. Again, back to the same thing. I am repeating this over and over again. Generalization of the encapsulation idea. Okay, put the related things together. Okay, put the data together inside a class. Put all the functions that work on that class and call it a class. That's one thing. The other things are, don't put anything unrelated to that class definition, including the data or the functions. But if you have such global-like functions, put them in some kind of a namespace or unnamed namespace, so that nobody other than your namespace can have access to them. So that will not make them global functions that are kind of limited. So that will solve our problem of where to keep these kind of global functions. Okay, so this problem was bothering me from the beginning of the semester, and I told you that we will find a solution later, and this is our solution in C++. Okay, if you have these kind of functions, okay, that you definitely need, don't make them part of your classes. Make it part of your unnamed namespace of the compilation unit. Okay, good. So this is our main function here, and everything is the same. So read hour definition is it. Okay, so this read hour, as you see, it just reads an hour from the keyboard, and this read hour reads hour from the keyboard. Its functions are completely different. Just their names, our signatures are the same, but their functions are completely different. Okay, any questions so far? Any questions from the online audience? I need to call this call, sorry. So let me, as always, okay, I will make a small. Hocam dersteyim, çıkınca arayayım mı? Tamam, görüşürüz inşallah. So let me go to this d time h, okay, and namespace. I put an unnamed namespace inside this d time h, and let's say function 1, and doesn't do anything actually, and let's say it returns an integer. Okay, so where does this function 1 go as the unnamed namespace function? Does it go to the compilation unit of the time CPP or time demo CPP? So remember, this is d time h, okay. I have three. Let me try to. Okay, I have d time h, this one, and I have d time CPP, and I have okay, time demo CPP. Okay, inside the d time h file, I placed an unnamed namespace, and I put function 1 in there, and I am including this d time h from d time CPP and time demo CPP. So my question is that function 1, what unnamed space does it belong to? Is it the unnamed namespace of the time compilation unit or the time demo compilation unit? Each compilation unit is, you may think it like G++ call. You say G++ the time CPP and G++ time demo CPP, right? You compile them separately, and there are two compilation units. So I know that there is a unnamed namespace inside this the time CPP. I placed read out in there, right? And there is an unnamed namespace in time demo CPP. I didn't use it. So I am saying that there is an unnamed namespace inside d time h. So do you think I am making a third compilation unit? No, it's not a third compilation unit. So what did I do? Where does that function 1 go? Which compilation unit? I placed my function 1. Are you listening to me at all? No. So which compilation unit does it belong to? Well, are you reading your messages? Yeah. Which one?
I think D times CPP unnamed spaces declarations.
My question is, choose either this one or that one. Don't make up another answers. Which one?
D times CPP.
A or B? D times CPP?
Yes, A.
But I am including this D time H inside from there too. Yeah?
I think it's neither because the file extension of
You are close, but it is not neither. It is both.
Oh,
Yeah.
fine.
It is both. So what did we say? What is a compilation unit? Compilation unit is a file along with all of it includes, right? in D times CPP, I have an unnamed namespace. I put some stuff in it, okay? But when I include this D time H, it becomes part of my compilation unit too, right? So if I define an unnamed namespace inside D time H, anything I put inside that unnamed namespace will belong to the unnamed namespace of the D time CPP compilation unit. Okay, and the same is for the time demo CPP too. So be very careful about your unnamed namespace inside your header files, because they will be included by other compilation units, and their unnamed namespace will be the same. That's why, I mean, it's almost the same problem or same feature of C, C++. That's why we are using the guards, right? Double inclusion stuff. Remember, I am including this D time H from this one and this one too, and there is a potential to include it more than once. That's why we have the guards. Okay, that's why we have the guards, and it's kind of the same thing is happening here. So you are including it in more than one place, okay, and the unnamed namespace of this compilation. The thing is that this becomes part of compilation unit of this one, also the part of compilation unit of this one, both of them. So anything you define inside the unnamed namespace of D time H will belong to both compilation units. Okay, that's why you don't usually see these kind of namespace definitions inside the unnamed namespace of header files, because they will be included and it will belong to many other compilation units. Okay, so are there any questions? Yes.
In the previous slides, there is already an.
You mean this slide?
Yes, this slide.
Yeah.
Can you zoom it to daytime H daytime?
You mean?
Yes.
Yeah.
There is already an unnamed namespace in daytime CPP, and we are including another unnamed CPP in the daytime.
Yeah, it is not another. We are just expanding that unnamed namespace with some more functions. Okay. It is no more different than doing this. Okay. Inside my header file, I define the prototype, and inside my implementation file, I provided the implementation. So I am adding more stuff to my namespace space 1. When I do that, I added more space to my unnamed namespace. Yes?
Can we implement two unnamed namespaces or together with compiler?
Can you implement what again?
Two unnamed namespaces.
Well, of course, I mean, the rule is this: each compilation unit has exactly one unnamed namespace. So by the definition implies you may have as many unnamed namespaces as the number of compilation units. Okay? But within a single compilation unit, you cannot have more than one unnamed namespace. It is just one unnamed namespace. It goes to the same unnamed namespace. And that unnamed namespace, again, like the global namespace, is available within that namespace, okay, like the global namespace, but it is only available for that compilation unit. Global namespace is available for all the compilation units, okay. There is only one global namespace for your whole program. Doesn't matter how many CPP files you have, doesn't matter how many compilation units you have, okay. There is only one single global namespace, but the number of unnamed namespaces is the same as the number of compilation units. Okay, I think there was a comparison between, where is it? Unnamed namespaces and global versus unnamed namespaces. It is not the same. Okay, with the global namespace, actually, just everything is in the global scope, and we don't like the global namespaces, etc. Actually, right? But whatever you're going to do with the main function, it has to be a global namespace function. Other than the main, I don't want to put anything inside the global namespace. Okay, so always make your namespaces part, your class definitions, your functions, etc., part of something. But unnamed namespaces are different. Okay, it has namespace grouping. It just doesn't have a name. That's why it's very useful for us to keep things local to the compilation unit. Okay, good. So without the unnamed namespaces, without the namespaces, everything would be okay, right? I mean, we have been living without the namespaces until last week, and nobody asked me any questions during the breaks about, okay, I am not feeling good about this and etc. So we were fine. So what did we achieve? Our programs will compile again. We are going to do the same thing. So what did we do? We just made this idea of encapsulation a little bit more global, okay, or more generalized. An idea of object-oriented programming, keeping the unnecessary data and functions hidden from the end user, is something that we like to achieve all the time. This is another mechanism for this, for the target. Okay, so unnamed namespaces. If you like to do like the nested classes, you can put namespaces inside the others. So it's called nested namespace, like the nested classes, inner namespaces. Inside the definition of namespace S1, I can have namespace S2. And if you like to call the sample function directly without using directives or using declarations, S1, S2 sample. This is how you do it. S1, S2 sample. Qualify names twice. Like the inner classes. This is available too. Okay, so that's what I did, and I told you about this. Hiding helping functions. Okay, helping functions are useful, of course, but sometimes they are not part of the class, and they are not public for public use. I like to hide them. Okay, either make them private static functions of yours. Okay, which kind of work for us, but I never liked them. Or to hide them from the outside world. Don't make them private. Don't make them static private. Okay, put them in a unnamed namespace of a compilation unit. Other than the compilation unit, nobody will have access to them, and so no problems. And it's nice to, I mean, you can give very generic names for your functions inside your unnamed namespace, like digit, int, or read minute. These are very, very generic names, like the function 1, function 2, etc. Because there is no way that they will be confused by somebody else's function 1, because these are local to me. Okay, good. So that's the end of the chapter, chapter number 11. This was about separating the implementation and the interface from each other. We talked about the header files and the implementation files, and then we talked about the namespaces. And I think I will stop at this point for this chapter, and I will start the next chapter if I don't have any questions. Any questions? Yes.
Is .h header file extension? I'm sorry, a file extension necessary? .h. Is it important?
I did not understand anything that you said.
The file extension .h for the header file, is it mandatory or?
No. Nothing is, I mean, I can compile, doesn't matter. If I tell the G++ compiler, compile a.txt, it will compile it. Okay? Sometimes .c and .cpp makes a difference, but there is an option that says, no. Well, when I say G++ a.txt, it will compile it as a C++ file. Doesn't matter if it is .h extension, .cpp extension. Okay, but of course don't do that. It's not a convention. always use .h and .cpp. Okay, and in fact, to include something, it doesn't have to be an header file. You may include other C++ files too in your program. Okay. Again, it's a bad thing, but don't do that. But it is possible. Yeah.
Should we use HTTP?
What?
HTTP. C++ header file. HTTP.
Can you include those files?
Should we use HTTP or H?
What? Oh, HPP.
Yeah.
Well, I heard people are using it for some reason. I don't remember, but nobody uses HPP anymore. I don't know why they had to use it. Was it because of the DOS? Yeah, maybe DOS had to have 3 letter extensions. I don't remember, but no. But standard is from 1970s. .h and .c or .cpp. Okay, but when I say standard, it is convention, not standard. Yeah.
Can I leave last one early?
Sure. Yeah. Go ahead. Okay. So let me start talking about our new chapter, which will be okay. What am I going to do? I am going to chapter 11. Okay, this is what we did. Separate compilation chapter 11. Streams, I am going to skip. I think Ilhan looked at it a little bit, maybe he didn't, but you know about the streams. You know how to use that stuff. And if you don't, just read that chapter. You are responsible from that chapter. You need to know everything about streams. And I'm going to talk about recursion today. Okay, let me open it up with my regular viewer. Okay, so the recursion you already looked at the recursion when you took C course. Okay, but since there is a chapter about recursion, I will talk about that too. But I don't want to start talking about, okay, recursion like you are starting to look at recursion for the first time. We will just go over it, and we will write a few recursive functions, and we will try to see what's going on when you do the recursion. But before that, let me try to tell you why we are looking at recursion at all. Okay, so if you write a recursive function, actually, okay, you are doing something mathematically sound, recursion has some fundamental roots in mathematics. Why? Because recursion is kind of imitating what induction does. Remember induction? Induction from your discrete mathematics course. Are you taking discrete mathematics this semester? Yeah. So they told you about proof method of the induction, right? Induction and what kind of other proof methods do you have? Induction, and you have proof by contradiction, and etc. So what do you do with the induction? Somebody say that, give me a proof that the numbers, the integers, the summation of the integers from 1 to n is n times n plus 1 over 2, right? And just give me a proof for that one. What do you do with the induction? You will say that if I make n1, okay, 1 times 2 over 2 is 1, it worked. If n is 2, 2 times 3 over 2 just worked, it is 3. So it worked for 1 and 3, 1 and 2, sorry. So what am I going to do? I will assume that for n is k, I will assume that it works, okay? And I will try to prove that, okay, when n is k plus 1, my original theorem holds. That's what we do. So how did we do this? We say that, okay, what is if n is k plus 1? I would do this. k plus 1 times k plus 2 over 2. Okay, what is this? I would say, if I take it at a parenthesis of the k, I guess, k times k plus 1 plus 2 times k plus 1 over. So this one I already know. This one is, okay, is the summation of all the numbers from 1 to k. What is this then? 2k plus 1 over 2 is just k plus 1. So if I add k plus 1 to this number, my proof would be complete, right? So this is induction. With the recursion, we are doing almost the same thing. We say that, okay, for the n factorial, I'm going to do this, or maybe instead of doing the factorial, why don't I do the same thing? Give me a function that will add all the numbers from 1 to k, okay? If k is less than 1, I will return 0, right? Because if k is less than 1, it is just 0. All the addition of all the numbers from 0 to 0 is 0. Then I will assume that, okay, I showed just one of them. Then I will assume that this function works fine for k minus 1, okay? So I will call this function with k minus 1. Whatever it returns to me, I will add k to it and I will return it. I mean, you see the similarity, right? It is exactly the same thing. Instead of making an assumption that if instead of showing that for small numbers it works, and for the large numbers assume that this one works, and the rest will come, I will do that, okay? So I am following the same steps as the induction. So in a way that by writing recursive functions, you are doing a mathematical proof. If you do it right, there is a mathematical proof that your function will work. This is a very rare opportunity, actually. I mean, it is very difficult to formally prove that your functions work fine, okay? But with the recursion, there is a mathematical proof, because if somebody tells you that your function doesn't work for some cases, for some integers, etc., you may show that it is not the case by running a proof using proof by contradiction. You say that, suppose my function doesn't work for some number where k is equal to, let's say, p, okay? If that doesn't work, that means that for fp minus 1, it doesn't work either, because I know this step is correct. If fp minus 1 doesn't work, then fp minus 2 doesn't work. And if I continue this idea, then I will hit this base case. Then that means that f0 doesn't work. But I know that the f0 works too. So by comparison, by proof by contradiction, I showed you that this function definitely works for all the integers, okay? It is really difficult, again, doing this kind of mathematical proof that your function works. That's why we like recursion a lot. We know how to write recursive functions, and what are the basics of the recursive functions? One part is the base case, the other part is the recursive case and combination. If you write sufficient number of recursive functions, and if you see a new recursive function, as soon as you look at it, you will see the structure, and you will understand what's going on, okay? They are actually easy to write, easy to debug, and easy to see what is going on, okay? Some people don't like it because it is at the beginning. It is difficult to write a few recursive functions, but it is not actually. It just takes a little bit practice. So all you need to do is just recognize the base case and try to figure out the try to figure out the recursive case, and after the recursive case, how do I combine this into the final results? Okay, so remember always, what you are doing is induction. Okay, what you are doing is not any different than induction. Assuming for some small values, proving that for some small values like 1 and 2 it works, and later coming up with this expression like call your function with a smaller number or a problem that is simpler, okay, and then combine the results to make up your final recursive result. Okay, so that's the kind of my introduction to recursion. Of course, they didn't talk about the recursion like this last semester. This would have been more confusing for you because you didn't take the discrete mathematics yet, and understanding these functions will take a little bit time. I think it's time for you to, this is a very good opportunity to learn recursive function writing. Also, it's a good opportunity to having a new way of looking at induction. Okay, so that's a little bit introduction to recursion. Instead of writing direct recursive functions, I will try to okay, show what happens with your recursive functions. Let's look at this simple function factorial, right? Our main function is here. I have a local integer m. I have a local integer n. I will call f with m and I will just return 0. So what is f? F takes a integer. Okay, if integer is less than or equal to 1, return 1. Otherwise, call f with k minus 1 and multiply, put the result in t1, multiply t1 with k, put the result in 2 and return it. So it's a factorial function. Okay, so I like to show you what happens when I run this program in memory. What does the CPU do? What kind of things we put in my memory, and etc. Remember our process structure. Okay, our process structure. Depending on your architecture, you have your program code. Okay, and at some place you have your globals and your heap. At some place you have your stack. Okay, and I will assume stack grows one way and your heap grows one way. Okay, so you don't have a global variables in here. Okay, you don't have any global variables. They are all local. How many variables do I have? 1, 2, 3, 4, and with this one is 5. There are a total of 5 local variables, but every time I call this function f, this 1, 2, 3 local variables, okay, the new spaces allocated on the stack, and there will be new k, t1 and t2s on the stack, and I will continue doing this as many times as I call this function f. So every time I call this function f within itself, I keep repeating, putting these stuff on top of the stack again. So that's what the recursion means actually. So I'm going to show you how this thing works. Today I don't have any time. Next time, and we will write a few recursive functions, and after that I will move on to our new chapter of templates. Okay, that will be it for today. Again, tomorrow morning we will continue from this point. Okay, see you tomorrow.